All right, so we're going to look at parent piecewise, and actually I don't think I put in the absolute value. We're going to look at a couple absolute value functions. So here are the 6 most common parent functions that we use in this class. So starting off with a constant, that's probably the one you won't see in this class. The second one is linear f of x. Remember, f of x is the same thing as y. So anytime you have y equals x, we can add in numbers in the middle at the end. That's going to be a linear function. Your absolute value, to know its absolute value, it's got to have these absolute value bars. And then your graph is going to look like a V. Quadratic down at the bottom, we've graphed quadratics. To be quadratic, you must have x squared. X has to be squared somewhere in there. A cubic function, you have to have an exponent of 3. And then the last one, square root, must have a square root in it. So you've got to have the square root of x somewhere involved to have a square root function. So these are just our parent functions. We're going to use them and modify them in the coming slides. So we're going to talk about translations or shifts. We normally just say the graph's been shifted. So there's 2 ways you can make shifts. You can make vertical shifts or horizontal shifts. So first thing we're going to talk about is vertical. A vertical translation or shift is made on a function by adding or subtracting a number to the function. Normally when you see that, it's just hanging out at the end. So in both of these cases, you have numbers hanging out at the end. The first equation's a linear, but that plus 3 at the end makes this translation right here. So you're translating up. So if it's positive, it moves up. If the number out at the end is negative, you're going to move your graph down. So for the second one, we have x squared, which is a quadratic. The minus 5, when the 5 is hanging out at the end, it's negative, it's going to move down. So any number hanging out at the end of your function is going to translate either up or down. So sometimes called vertical shift up, vertical shift down. A lot of times you'll see the word shift instead of translation on your tests. The second type of shift we can talk about is a horizontal. Horizontal is either going to move you left or move you right. That happens when you add or subtract to the variable. So keyword here, variable. It's no longer hanging out at the end necessarily. It's going to be stuck in with the variable. So if I look at this first one, this 2, the parent function is x squared, but we shove that minus 2 in with the variable. When it's shoved in with the variable, it has the opposite effect of the sign. So the minus 2, actually moves you to the right. We're not moving down. Mark that off. So that minus 2, since it's in with the variable, it's moving you right 2 units. So in this case, if it's negative, you're moving to the right however many units. The second one, we have a cubed root. Again, the plus 4 is put in there with the x. It's not hanging out at the end. It's in underneath that cube root with the x. That's a translation to the left. So a positive actually moves you to the left. So kind of opposite on the inside is what we normally think. And then again, translation to the right is called a horizontal shift right. Translation left or shift left can also be called a horizontal shift to the left. What that actually looks like on the next page, maybe. So here we're going to look at the example, y equals the absolute value of x plus 2. So our parent function is the absolute value of x. So that's actually graphed for us already in red. We're going to graph the new function according to the given shift or shifts. In this case, we only have one number, which means we only have one shift. We have to identify whether this +2 is hanging out at the end or if it's inside with the x. So we have to decide if it's inside, it's going to move us left or right. If it's out at the end, it's going to move us up or down. What do we think? So it's going to move us up or down because it's not in the absolute value bars. In this case, we're moving up by 2. So we're going to take each, I would just use these 5 points. So I'm going to use these 5 points and we're going to move them up 2. Well, the top 2 actually won't even fit. So when I move this point right here up 2, I'm going up 1, 2. And I'm going to put my new point right there at -1, 3. Then I'm going to look at the order pair at 0, 0. I'm going to move it up 2, which moves it to 0, 2. And then last one that'll actually fit on my graph. I guess I could put another one. 1, 1 is going to get moved to 1, 3. You could do this point here and move it up here. You get the gist. And then we're just going to connect those to make our shifted graph. There is one question on your next test that asks you to do this. So it's actually just going to give you a graph and tell you what transformations to make. You just have to pick points and move it accordingly. I want to say it's a quadratic on your test, not an absolute value like this. So for this one, or these, I think next 2 slides, this one and the next one, we're going to identify the parent function and then we're going to list the transformations that are occurring. So looking at question number 1, the parent function, just go back to the bare bones. So we're getting rid of any addition and subtraction. We're just looking for the parent function. In this case, it's just x squared. So you could put x squared or you could write quadratic. And then the transformations. In this case, we've only got one occurrence of addition or subtraction, so we only have one transformation happening. This -6 is hanging out at the end. It's not in with the variable. Remember, if it's in here with x, it would have to be in parentheses before the squared. So this is hanging out at the end. When a number is hanging out at the end, it moves you up or down according to the sign. In this case, you would move down 6. Question number 2, f of x. Remember, f of x is the same thing as y. So y equals the absolute value of x minus 1. So original is absolute value of x. So you can either just write absolute value or you can put absolute value of x. Either way works. You don't have to write both. And then the transformations. This time when I look at my transformations, the -1 here is not hanging out at the end. It's actually inside the absolute value bar. So that's going to move me left or right. Remember, if it's inside with x, it's going to go opposite. So instead of moving -1, it's going to actually move +1, which is right 1. take a second and see if you can do question number 3. So identify the parent function, and then tell me the transformation that that plus 4 does to your parent function. Hopefully you decided that that parent function was the square root of x, or just the square root function. And your transformation, that plus 4 was not underneath the square root, so it's translating or shifting the parent function up by 4 units. On the next slide, we're going to make things a little bit more challenging. So notice that on this slide, we have 2 numbers. So we have 2 transformations happening to our parent functions. So for question 4, our parent function, if I take away the 1 and the 3, leaves me with just x squared. So it's a quadratic. And then I have to look at both of these numbers. So I know, since I have 2 of them, that one of them is going to shift me left or right. The other one's going to shift me up or down. I just have to pick the right one and write the correct direction. So I'm going to start with the hardest one first. Hardest one's the one on the inside. Inside moves you left or right, opposite of the sign. So a plus 1 does not move you right. It actually moves you left. And in this case, you're moving left 1. And then we're also making a second shift. The plus 3 hanging out at the end keeps the sign, moves you up or down. Since it's positive, we're moving up 3. So our transformations here, left 1 and up 3. For question number 6, our parent function is the absolute value. And then we have, again, 2 transformations. The plus 5 on the inside moves us left 5. And then the minus 2 hanging out at the end moves us down 2. So our transformations for this one, left 5 and down 2. Take a minute and see if you could do question number 7. Hopefully you identified your parent function as being the square root of x, or the square root function. Your 2 transformations, the plus 2 that's involved directly with the x inside moves you left 2, and the minus 5 down at the end moves you down 5. Now we're going in the opposite direction. So for questions 10 through 14, we're being told the shifts, and we're going to have to write the equation. So here we have given an absolute value function. So we know we have absolute value of x somewhere in our problem. We need a shift down 5. So vertical shift down 5, that's going to give us a -5 somewhere. And a horizontal shift right 3. Remember, horizontal shifts take the opposite sign. So I'm going to have a -3, and that's going to go inside. So for our equation, I'm going to write y equals absolute value of x -3. That shift to the right 3 goes inside. Your other absolute value bar, the -5, hangs out at the end, outside of your absolute value bars. Question number 11, we have a linear function. Linear is just x, and all we're being told to do to it is to shift it up 5. Shifting up 5 just hangs out at the end, so y equals x plus 5 would be my equation. Question 12, we have a square root function, so square root of x. If we're moving down 2, that goes outside. If I'm moving down 2, it's going to be a -2 on the outside. Our horizontal shifts go inside. If I go inside, I have to go opposite. So if I'm going left, and normally it's negative, but since it's inside, I've got to write +7 on the inside. So for my equation, y equals the square root of x, and then on the inside, I need +7. On the outside of my square root, I need -2. For question 13, we're told to use a quadratic. Quadratic's just x squared. And then we're using a horizontal. Horizontal shifts are inside. And then I want to shift left 8. That would be a +8 on the inside. So y equals x plus 8 in parentheses squared. Question 14 is written a little bit differently. So question 14 tells us we have a quadratic. That's normal. They're telling us to use x squared. But then they've told us that the vertex is at -5, -2. So here you have to know that the parent function has a vertex of 0, 0. If I have my vertex at -5, -2, that means I've gone left 5 and down 2. So really they're telling us write a quadratic that's been moved left 5 and down 2. So the left 5 has to go inside your parentheses. If I'm moving left, it's actually inside positive. So x plus 5 in parentheses squared, down 2 at the end is the -2 hanging out at the end. There are only, I believe, 2 questions on your test that you have to know the shifts for. One of them is going to give you an equation, like on the last slide, and you're going to have to identify the 2 shifts. The other one's going to give you a graph of a quadratic and an equation that you have to shift accordingly. So you have to identify the 2 shifts and then move the original graph. So up to now, we've been looking at functions that have been represented by a single equation. However, in real life, there are functions that are represented by combinations of equations, each corresponding to part of the domain. So these functions that we're going to look at next are called piecewise functions. There's actually a bonus question on your next test and your final that deal with piecewise functions. So a piecewise function is a function that is a combination of one or more functions. The rule for piecewise functions is different for different parts or pieces of the domain. So depending on the x value that you're given, you're going to use a different equation. So for instance, movie ticket prices are often different for different age groups. So the function for movie ticket prices would be assigned a different value or ticket price for each domain interval. So for each age group, they would charge you a different amount. So here's an example of what a piecewise function looks like. So f of x is just our function notation for y. And then here we have two pieces. So it breaks up into two parts. One equation, this equation right here, is what we use if, keyword if, we have an x value that's less than or equal to -1. So here's the restraint on my domain. So if I have an x value that's less than or equal to 1, I'm using that purple circled function. If, however, I'm given an x value that's greater than 1, I'm going down here to the bottom, and I'm going to use this underlined portion. I'm going to use 3x plus 1. So one equation is used if x is less than or equal to 1, and the other one's used if x is greater than 1. So we have two different options. You just have to figure out which one you're using at the appropriate time. So here we're being asked to evaluate f of x when x equals 0, x equals 2, and x equals 4. Keep in mind, you will never use both equations for one problem. So really we have three problems here. We have to find a y value and x equals 0 and x equals 2 and x equals 4. So if I look at x equals 0, I have to determine which one of these two constraints that falls into. If x equals 0, is x less than 2 or is x greater than or equal to 2? Well, x is less than 2, so I know that I've got to use this right here. So since x is less than 2, I'm plugging that 0 into x plus 2. So 0 plus 2 just gives me 2. So if x equals 0, y equals 2. Then we're going to go to the second problem they gave us. They said, hey, find y, or f of x, when x equals 2. So this one sometimes tricks students because you have two 2's listed here for your constraints. One of them, however, has equal to underneath. So this little line down here at the bottom says x is greater than or equal to. So we actually have to plug into the bottom for this one. So when x equals 2, we're plugging into 2x plus 1, which is 2 times 2 plus 1. 2 times 2 is 4 plus 1 is 5. So when x equals 2, I get a y value of 5. And then the last one, they're telling us x equals 4. If x equals 4, we again have to determine if it falls into this category or this category. So is my x value less than 2 or greater than or equal to? Most definitely greater than or equal to. So I'm going to again plug into the bottom equation 2x plus 1. So 2 times 4 plus 1. 2 times 4 is 8 plus 1 gives us a value of 9. So if you're being asked to graph these, So for this one, we were given a new piecewise function. Our constraints have changed, so now we're using the top if x is less than 1. So for all x values, we're using the top equation to graph. So any number that's to the left of 1, we would use it to graph. And then we would use the bottom one for anything to the right of 1, including an x value of 1. So here, if we actually went ahead and graphed this, it would look like this. Oops. So here we have 1/2 x plus 3/2 graphed in red. So this is in red. Whoops. This is in red. So you can pick any value and plug in for x into the 1/2 x plus 3/2, and they're just going to give you order pairs. So if you plug in 7, it looks like you're going to get a value of -2. Like it's just going to give you points along here. It looks like that one's 1, and this one's 1, this one's 1, all those points. Then you just connect them. The blue portion of this graph is the portion over here to the right that includes 1. So any number greater than or equal to 1, you plug into that blue equation, and it's going to give you values along it. So it's going to give you all of these points depending on what x values you plug in. You just connect them as normal. So notice that these two lines both meet at 1. Sometimes that doesn't happen, like this graph here, maybe. When that happens, it's called a point of discontinuity. So that just means your graph isn't continuous. You can't draw it with one pencil sweep. So here you would have to pick your pencil up when you got to 4. Shouldn't be 4 though. That should be a 4. These should be 4s. But you won't normally see this. This is just something to be warned. Like they don't have to always meet in the middle. Sometimes they look wonky like this. There's not one swift movement to get there. We're going to do a little bit more practicing on finding y values. In this case, we're being asked to calculate f of -2. We have to decide which portion does this fall underneath. So if I'm asked to find f of -2, I have to figure out which one of these two constraints -2 falls underneath. So is it less than 0 or greater than or equal to 0? In this case, it's less than 0, so I'm only using this top information. So f of -2 equals -2 squared plus 1. -2 squared is 4 plus 1 is 5. Your turn. I want you to evaluate these 4 x values. So I'm giving you 4 x values. You have to decide which one of those 2 constraints it falls underneath and plug it in to find your answer. Hopefully you got these 4 answers. -3, 2, 12, and 4. Anybody have questions? One more just for fun. We're going to evaluate the following. So we're going to find y values for f of -2, 3, -4, and 1. But notice this piecewise function has 3 different options. So here we have an option for when x is less than -2. So we're going to use 3x minus 2 anytime x is less than -2. Here in the middle looks a little bit different. So the portion here in the middle, when I have an x value between or equal to -2 and +1, I'm going to use the middle one, so -x. And then last one down here, if I have an x value greater than -1, I'm going to use the last option. So really the only thing new is we're putting that middle one in there for a middle value range. So when I look at the values I was given, I first of all was given f of -2. So I have to figure out which one of these 3 categories does -2 fall underneath. Is -2 less than -2? Well, no, it's actually equal to. Since it's equal to, it falls under this one right here. X is greater than or equal to -2. So I want -x, which just means take the opposite of x. Opposite of x is +2. So -2 becomes +2. If I find f of 3, 3 falls into the last category of x is greater than 1. So I actually have to take and follow this right here. So I'm going to take 3 squared minus 7 times 3. Let's see. -12. -4 falls under which category? First, second, or third? First. So -4 is less than 2. Since -4 is less than 2, we're going to use 3x minus 2. So we're going to take 3 times -4 minus 2. 3 times -4 is -12, minus 2 is -14. And then the last one, f of 1, means I have an x value of 1. An x value of 1 gets kind of tricky because you have 2 1s here. But notice this one equals 1, so I've got to use that third one. So I'm going to use x squared minus 7x. Oops. So 1 squared minus 7 times 1. Well, 1 squared is 1. 7 times 1, 7. So 1 minus 7 is -6. Questions on these?